So I will. We have now around let's say 20 minutes to take question. We have had really few to the time being. So if you have any question in the meantime, please do not hesitate to pose them, and we will try to answer them as best as we can. So first question was from Andrew Want to Guillaume. Do the NORSOC and the DNV guidelines provide details on the methods they use to determine the biofouling metrics?
Yes, thank you, Andrew, for this interesting question. To be honest, to our knowledge, no, we don't have any details about the reference which are used, and we tried really to find it, but I think it perhaps it's lost in the pipeline for with the years and time. I don't know, but yeah, we don't have an idea of the methodology which have been used for the reference values, which are the origin of the recommendation. It's something a bit mysterious, and typically, I think perhaps it joined a bit question also from Rémi Ledru, but yes, we have some discussion for sure, more with BV, because we are working with them on other topics. But yeah, there is still a lot of things to do, and the idea to present this work on the OMA conference was also to make people aware about the need to improve this, and also because this is one of the conference which is widely used by certification body to has a reference to make improvements on their recommendation, etc. So that was the idea and the reason why we targeted this conference. So I hope that this will change soon, and perhaps as a testimony in the audience, we have a lot of questions. Attendees were because it's more an engineering community at this conference, but we had a lot of questions and interest, and also from DNV. So hoping that this will change soon.
Thank you, Guillaume. Maybe also to complete what you were saying about the NORSOC, it's just to remind everyone that the standards were developed in the 70s, let's say, with data in the 70s. So that's why maybe we lost a bit the track of how they were obtained, and they were derived for the oil and gas sector in the North Sea. So that's why also we believe that they are not completely applicable to some of the offshore wind contexts that we have in France. For example, what we have seen in the Mediterranean Sea, and the first observation in the Mediterranean Sea that is warmer, much more warmer than the North Sea, shows that the dynamics are not really the same. Hence the need to progress on the knowledge of biofouling in those areas.
Yes, you're right. If I can add just something, it's important also to know that almost all of them specify that the best practice is to have some in situ data. So don't forget that the data we are speaking about, the 100 millimeters of thickness, etc., are the default value, but they recommend for sure to have in situ data. So that's the reason why we wanted to say, okay, we need in situ data, but how to measure them? And it's not so evident. That's the reason why we perform this investigation. And but yeah, it's the next step. Okay, in situ data, but how?
Okay, maybe the other question from Rémi Ledru. Did you make comparison in terms of final results on the mooring cable, tension, curvature between the actual marine growth model proposed by the standard and the one you are proposing? What is your order of magnitude of this influence? Guillaume, I think as well it's engineering, so it's for you.
Yeah. Thank you, Rémi, for your question. Yeah, for sure, this is clearly the exercise to perform. And it was clearly scheduled in the project at the beginning. Unfortunately, this is the occasion also to testimony about the difficulty to make some offshore measurements. We had some severe unexpected event with bore throttling, so we had all our samples, and to cover this event and to have some mitigation strategy. So finally, we had some data to present and analyze, but we unfortunately had to remove this task. So this work is still to perform, and for sure we need to perform it. But perhaps I can share with you, because I have the chance to be at Tokyo. I discuss also with Japanese people from NMRI, which is working on certain biofouling, so on the prototype in Japan. And an interesting point is the fact that in both cases, so Fukushima and the NEDO prototype also, um, uh, before 2 years, they have a strong change in the W shape of the on the cable geometry. And for NEDO, they issued a paper, but it's in Japanese, so it was easier for me to understand in discussing directly. But yeah, the cable was laid on the seabed, so it was in a 60-meter water depth using a W shape with a tether on the second buoyancy section, and the weighing second catenary part was laid on the seabed before 2 years. So because they used the W shape with tether, they anticipated the fact that this will change with biofouling weight. But despite this, yeah, it was this non-expected scenario. So yeah, for dynamic cable especially, this is a topic.
Okay, I will just jump in another question from Richard Lefayet because it's for RT and the other one are also for you, Guillaume, so it's
Yes.
to change a bit the public.
Okay.
Lisa, maybe Bertrand is online and it can also give some answers. Did RTE and contractor responsible for the dynamic IAC design aligned on the design criteria, clearance with surface, seabed during design stage, or were similar criteria used during the iteration of the mooring design? So yeah, it's a really technical question. I don't know if Bertrand is online or if you have the answer, but
well, I don't
yeah.
have the answer, that's for sure. So if Bertrand is there, can it?
Yeah, okay. Bertrand, I think you cannot participate, so maybe if you can answer the question in the Q&A if you are there. Otherwise, for Richard, we will try to answer him by email later on. Okay, just going back to the question, there was a question from Arun Rashid. Can image-based biofouling assessment reliably replace traditional biomass and scrapping methods? Wow, such a good question, Guillaume. I know
Yeah.
that you have a lot of elements of response for that.
Excellent question, Aaron, and a very interesting question. And I think that you are on the future methodology. But yes, we want up to date, no. But this is typically something we want to go on because scrapping method is heavy to make and complex. And if we project it on the farm and the service time for next generation, because we have the specificity of the renewable energies to have a lot of production units regarding other energy system. So yeah, this is really an issue to scrap systematically. So this is the idea, but for that, we need to build a robust database, so meaning with a coherent and reliable protocol, okay? And then we need to propose a database where we will be able in the future to predict, depending of the distribution of the community we observed, so from image, for example, we are able to associate a coherent density, why not porosity, depending on the age of species, etc., and then to derive some more accurate parameters. This is a goal, yes, clearly an objectives, but for that there is a lot of work to do. We need to build this database. But yes, it could be very, very efficient.
Thank you, Guillaume. And maybe we'll get into that later, but that's also a topic that has been already studied in a BioPlus project, where you try to also begin, let's say, the work on this thematic. And it's also something we would like to work on a new project that we will be launching at the end of the year that is called Quantum, and I will present a bit later on. New question from Eshan Ali. What is the meaning of roughness in biofouling and its estimation metrics? Again, sorry for the other one. It's for Guillaume. A lot of questions related to engineering.
Yes, when we're speaking about roughness, this is mainly to describe the surface state and the impact on the surrounding wake in terms of flow and fluid dynamics. And why? Because it's usually used to take correction coefficient from the literature and to of hydrodynamic loadings. So typically the drag, eventually the lift, but not often, added mass, etc. This is used for that, but where your question is interesting is the fact that roughness is, yes, normally it's a surface state, but in the case, again, of dynamic cable or mooring lines, the protuberance represented by the biofouling is have a size which is almost comparable to the object. And that's a main limitation, because in the literature, because it's just describes the surface state, we are speaking about a ratio, so height of protuberance regarding the component, the colonized component. The ratio generally is the maximum ratio you can find in the literature is 0.01. And in our case, on a dynamic cable, very quickly, the biofouling will provide some ratio which is close to 1 or 0.1 at minimum, but quickly close to 1. And typically, I don't think we can still speak about really roughness. So we perform a basin test on a specific on that on another project we didn't speak about today with muscle cover, and we speak about macro roughness, but typically, to be honest, your geometry is changing a lot. And in our case, we represent a muscle cover using 3D printing, so highly with high fidelity. And locally, this drives the flow and will affect a lot the hydrodynamic loadings. And we had some higher hydrodynamic loading than using the roughness approach from literature. So that's the reason why I mentioned these 4 group of species and the needs to perform some basic tests and to improve the database. Because for such component, dynamic cable mooring lines, because of their initial size and the size of biofouling, we are in front of, hydrodynamic coefficient, which are not really already present in the literature. So I hope it answers to your question.
The answer is complicated answer that we still have to work on.
It's an hydrodynamic aspect.
We have another question from Thomas Hullard. Do you envisage a scale effect between sampling and real size cable for engineering, but not only? So I think you have already studied this aspect within ETAL experiment that you presented, Guillaume, and maybe you can give some insights on that.
Yeah. That one of the main motivation of ETAL experiment, to assess if, for sure, when we are in characterization phase, we want to deploy some simple samples, because it's very difficult to deploy offshore. It's a very severe environment. In that phase, generally, we are obliged to use small floater buoys, and on that floater, the dynamic is higher on the huge floater of floating wind turbine. So it's a real challenge to not lose our samples and get some long-term data. So for that reason, we study the effect of size. And yeah, in the ETAL experiment, the smaller diameter was 14 millimeters and the higher was 120 millimeters, so almost the size of nylon rope of wind turbine, which is close to 200 millimeters between, yeah. And for the same materials, for the different diameters, we expected that some, I don't know, some species for reason of competition and size are not able to hang on the samples. That was the initial question. And for that, we didn't found real differences for a given material with different diameters. So from that, we expect that we don't need to use a scale effect. That's our first conclusion. Yeah. So if it's the question, yeah, at the moment we don't see any reason to use a scale effect to derive data for the final application.
Okay. Thank you, Guillaume. Then we had a new question from Eshan Alai. Is the dataset used for V2 design omega in biofouling on slide 12 and 13 publicly available? It is not, but you can get in touch with us to discuss the conclusion. If there is no other question in the chat, maybe I had one for Lisa. We've seen that the site characterization and the comprehension of biofouling ahead of the installation of the dynamic cables was quite important. To my knowledge, to date, is there any recommendation for the environmental survey to gain data or to acquire data in the first phases of environmental impact assessment or not? And from your experience, would it be something that would be useful to plan, for example, for the future AO or substations that will be planned floating offshore?
It's not something that we need to do. So we are not following the biofouling, and it's not reglementary. And for the second question, I don't think I can't answer alone at your question. I think it's interesting to following the first stage of biofouling in terms of fundamental research, because it's the first stage. And so you better understand the dynamics of the ecosystem in open sea, and you can do it at different depths, and you also know the communities, so you can understand yes, what's happened far away from the coast, and so for me it's interesting in the fundamental research to better know the ecosystem and the dynamics. Now for regulatory, I'm not the person, because I'm in charge of research. Yeah. So
okay. Well, thank you so much. And finally, maybe you have time for a last question, and it's perfect because it's one for Jean-François. What is meant by DNA extraction from scrapped biofouling samples, and what are its benefits? Your mic is off, Jean-François.
I don't understand the beginning of the question, so.
I think they do not understand how is performed the DNA extractions from scrapped biofouling samples.
Okay, so as I mentioned, this DNA extraction was developed in the previous project, so it was in ABIOC+, and we tried to different approaches, because of course to extract the DNA we have to break the cells, but if we if the methodology is too hard, the risk is to also break the DNA and then to have a very small pieces of DNA which are not easy to amplify after. So we tried different type of extraction method with different beads, especially. And finally, the one we select, it was with, and we published this study, this study, allow us to have the better representation of the community. So it's technical approach. It's really such DNA extraction methods really depend on the type of samples. So that's why it was really important to develop a specific method for biofouling, including all the hard species that we talk about, because it's not very trivial to extract this. Of course, when you have a great high number of muscles, for example, we still have some issue with the extraction process, and we have to proceed a little bit differently.
Okay, thank you. And maybe also to add that usually for environmental survey, eDNA is sampled in water. And what we have done that is quite innovative in this project is to look at it in the biofouling, which is quite different and would have different protocols and taking it in water, and maybe gives also other results, even if we have not compared the two. Do you agree or not, as I'm not an expert in the field?
That the way to extract is different from depending on the matrix. Yes, this is a little bit what I said. It's you have to adapt the DNA extraction protocol to your matrix. Of course, it's more difficult to extract from biofouling than from water, but you also have much more higher amount of DNA. So yeah, it depends. It depends on the question and depends on the places, of course, too, as we mentioned in several times today. The type of biofouling is really depends on the environmental condition, and so the type of organisms. And Guillaume talked about that because he said that only two type of biofouling, hard and soft, is not enough to have characterization, and it's the same for DNA extraction. So we have a huge diversity depending on the site, and of course you have to be able to understand what is happening. You have to first characterize the biofouling at your site and in your condition.